Well, our topic tonight is separable differential equations. And quite a few people have asked for a review on this, so I would just want you to take your time. The first one's pretty nice, and then the next two get a little tricky. So I've got a total of 3 problems for you tonight. Take your time, like I said, and let's make sure that we can perfect these questions at any moment in time. All right, question 1. Find the particular solution to dy dx equals 3x squared plus 1 over 2y, and, oops, I left off, given this initial condition, f of 1 equals negative 4. All right, so my first move is, remember, these are separable differential equations. We need to separate the variables. And I just want to remind you that your dy and dx need to be in the numerator. Okay, so usually the easiest thing is just to simple cross multiply. The other thing I just want to take note of is that this function stays together, okay, and this function stays together. So I'm saying it's 2y dy equals the quantity 3x squared plus 1 dx. Now, that only took one move, and the variables are separated. At this point, we just slap that integral symbol around each side, 2y dy, and integrate 3x squared plus 1. Nothing fancy here, no u sub, nothing tricky, just a nice simple integral. So I'm going to get y squared equals x cubed plus x, and don't forget that plus c. There are no bounds, these are indefinite integrals, so we get that plus c, and we just keep it on the one side with the x. Now, we're going to solve for that c value next, and we had that initial condition, f of 1 equals negative 4. So this is going to turn into negative 4 squared is 16. I've got 1 plus c. So I would say c equals 14. Okay, once I've got that c value, we make that quick substitution into our original equation. So y squared equals x cubed plus x plus 14. And here's the most important step. When you take that square root, they're going to be looking for this. Okay, we need to show that y equals, when I square root, plus and minus x cubed plus x plus 14. And then at this point, you'll determine whether you want the positive or the negative radical. Now, it's very simple. You just look at that initial condition. Remember, it was f of 1 equals negative 4. That means when you plug the number 1 into this equation, I need to see a negative 4. So I think mathematically it makes sense. If I plug 1 in, I'm going to get 1 plus 14, so I get the square root of 16. And if I want to see a negative 4, that's telling me I only want to see the negative radical out front. So my final equation is just y equals negative square root of x cubed plus x plus 14. Okay, so moral of the story here, whatever this initial condition is, that will tell you the sign if you have a square root. Now, I just want to be, clear quickly. What other roots would have a positive or negative out front? If you took the fourth root of something, you would get plus or minus, the fourth root, if you wanted to take the fourth root. However, if you took the cubed root, okay, you are not getting a plus or minus. All right, it's just on those even-powered roots. All right, I only have 2 more for you, so stick with me. Number 2, find the particular solution. dy dx equals xy plus 2x, and f of 0 equals negative 4. So recall, the only way we can separate the variables is multiplying or dividing. You cannot just take this xy and subtract it over. It doesn't work that way. You can only multiply or divide. So basically, I'm saying to myself, I don't want to see 2 x's here. What could you do? Just think, basic algebra. Hopefully you're saying you could factor out an x. So I would say dy dx equals x times the quantity y plus 2. Now I've kind of separated the x and y, and again I would cross multiply and separate my variables. So I'm going to get dy equals the quantity x times y plus 2 times dx, and of course I want the y's to the other side, so I'm going to divide both sides by y plus 2. So sometimes it takes a few steps just to separate the variables themselves. So I've got dy over y plus 2 equals x dx. Okay, now I'm officially separated. I'm just going to slap that integral on both sides. All right, I'm going to start on the right side. That's a much easier problem. The integral of x, of course, is just x squared over 2 plus c. Now the left side's fairly annoying. You can't just make it up in your head. You need to do a simple u sub off to the side. U equals y plus 2. du is equal to dy. So I'm still having the integral symbol here. And I've got 1 over u, and my dy turned into a du. Okay, so I still need to integrate, and I'm going to get the ln of the absolute value. Watch that absolute value of y plus 2 equals x squared over 2 plus c. So again, I just want to stress that we have that absolute value there. Now, our initial condition was f of 0 equals negative 4. So I'm going to quickly substitute those in. So I get the ln of the absolute value of negative 2 equals c. All right, now this is a big deal, and this is the one thing a lot of us keep missing, or that's frustrating us. All right, so let's pay special attention here. Notice, I don't know what the ln of negative 2 is. It does not exist. If I picture my ln graph, there's an asymptote at 0. The ln of negative 2 doesn't exist. But the absolute value is so important because it now changes that negative 2 into a positive 2. Okay, but you have to take that into consideration later on. So at this point, I'm going to substitute my c back in. So I'm going to get the ln of the absolute value of y plus 2 equals x squared over 2 plus the ln of 2. Now, you're probably saying in your head, I can use a zap rule. I can get rid of this ln by using a zap rule. There's nothing in front of it, so my zap rule works. I'm just going to raise both sides to the e, okay, or exponentiate. So it's e to this chunk. Whatever I do to that side, I need to do to this side. Now, those zap out. But again, here I'm stressing it again. The absolute value does not disappear yet, okay, because technically it's plus and minus. We have to determine which one we want to see. Oops, e to the ln of, that plus 2. Okay, we have to determine which that we want to see, the plus or the minus. Okay, there are two ways to think about this. One way is to say to yourself, back here, I had the ln of negative 2, and then I had to switch it to a positive 2. So because I had to change signs, that means this number is going to be a negative. Okay, if that doesn't sit well with you, think about this. The initial condition was f of 0 equals negative 4. That means when you plug 0 in this equation, you need to see a negative 4. Do some quick mental math. If you plug 0 in here, okay, I'm going to get e to the 0 plus the ln of 2, which would be e to the ln of 2, which zaps out, which gets me 2. If you just left this as y plus 2 on this side, and you subtract the 2 over, you're going to get 0, and you need to get negative 4. That means you needed to negate this side and say it's negative y minus 2 equals 2. Now you get negative y equals 4, or y equals negative 4. Okay, so if you can't just buy the fact that this changed signs here, and that means you're going to use a negative, then take the 20 seconds, plug the number in, and see which one you want, a positive or a negative. Okay, so let me kill this for a moment. So I'm saying I get negative y plus 2 equals e to the x squared over 2 plus the ln of 2. Distribute my negative, e to the x squared over 2 plus the ln of 2. Add the 2. And then divide by that negative. So you should get y equals negative e to the x squared over 2 plus the ln of 2 minus 2. Now, there's one other big deal in this problem. All right, and that's right here. They're going to decompose this. And what do we mean by that? Well, when you see addition in the exponent, you can break that into multiplication. So I could say this is, I'm going to ignore this negative for a minute, e to the x squared over 2 times e to the ln of 2. That's a zap rule. So I really get y equals negative 2 e to the x squared over 2 minus 2. And there you have it. All right, question 3. Find the particular solution to dy dx equals y minus 1 over x squared and f of 2 equals 0. So pause it, try it on your own, separate the variables, and then meet back with me in a few moments. So hopefully your separation looks like mine. I did a simple cross multiply, and I've got my variables separated. I'm going to go ahead and integrate. Again, pause it, see if we get the same thing. Take special note that I have that absolute value here. Okay, so let's just be careful with that. I'm going to use that initial condition. So I get the ln of negative 1 equals negative 1/2 plus c. So again, what this is telling me is I don't have the ln of negative 1. It does not exist. So I can change that into the L1 of the ln of 1, which of course is 0. But because I changed that, remember, that's going to affect my problem later on. So I get a nice c equals 1/2. Take that bare substituter back in. All right, the big moment of truth. We're going to exponentiate both sides, so e to this side, e to this side. All right, you can zap those out, but you have to say it's plus or minus the absolute value and then determine which one you want. Okay, I have to determine if I want the plus or if I want the negative. So again, you can just know because we switch those signs, or say to yourself, when I substitute in a 2, I need to get out a 0. So I hope you can solve that in your head. If you were to leave it, and this is kind of just show you what's going through my head here, if I were to leave it as is with a positive y minus 1 equals e to this junk, okay, and I plug in the 2, I'm going to get e to the 0, which is 1, so I get y minus 1 equals 1, y equals 2. That's not what I want. Okay, so I know that fails. It's not the positive value. All right, I have to use the negative value. So I'm going to say it's negative y plus 1. I'm taking that negative and distributing it. Equals e to the negative 1 over x plus 1/2. Now just double check that math. If you did that correctly, when you plug in 2, you should get 0. So negative y plus 1 equals e to the 0, which is 1. Subtract 1, negative y equals 0. Therefore, y equals 0. I know that works. Lastly, I just need to solve this equation. So I get y equals, I'm just adding the y and subtracting that over, 1 minus e to the negative 1 over x plus 1/2. Now, this answer is perfectly correct. I am going to go one step further and decompose. I just want to get that through your head in case it's a multiple choice question. This piece can get decomposed because if I added exponents, that means I must have been multiplying. So I could say it's y equals 1 minus e to the negative 1 over x times e to the 1/2. Just want you to remember that decomposition is allowed. All right, in your notebook tonight, dy dx equals x squared times the quantity y minus 1, and f of 0 equals 3. We'll be checking this tomorrow, and have a great night.